Greetings! Today we're finishing the Sudoku solver and my Java tenure, which has been a couple months, and I've learned a lot. I had known nothing about Java, and now I know some things. Anyways, what needs to happen today? We need the computer to plug in. So we last video we did the validator, which checks to see, it goes through numbers and it's like, is this number a valid move? Can we put it in this column or row or box without it infringing on the rules of Sudoku? So yeah, we need the computer to plug in a valid number 1 through 9 for each cell of the board. But if a number placed compromises the rest of the board, it needs to go back, and this is called recursion, backtracking. So basically in a Sudoku, when you put a number down, it could be valid in that moment, but then it could compromise another number when you go through the rest of the puzzle. So what we need is, we need the computer to, if that happens, we need it to go back and try a different number. And that's the hard part. It's like some pretty crazy logic that I'm going to try to explain to you the way that I interpreted it. Let's learn. This is going to be, I'm only making 2 methods, but there's a lot of explaining that I'm going to have to do to prove to me that I know what I'm talking about. Let's code.
Let's do this.
Let's do this. Here we have the validator, and I just ran this, so there's no bugs. And our main, which has our grid. And since we're doing object-oriented programming, we're going to make a new class for our solver class, and we're going to call this solver. Solver class. Nice. All right. First things first. We need a new method, and this is going to be the logic for our solver, and it's going to have a bunch of nested for loops. Let's go public static Boolean. We're using a lot of Booleans because we just want to know, is it there? Is it not there? Will it work? Will it not work? Solve board. And the parameters we're using, keep it very simple. We're going int our 2D array Sudoku board. Oh my god, there's going to be a sea of curly braces. So brace yourself. So the first thing we're going to do, we need to tell the CPU to check every single cell. And to do that, we're going to have it iterate through all the rows and columns. So you've probably seen this before. And this for is going to be highlighted with a little underlined right here because it's waiting for a return statement. We're going to get to those later. For int row equals 0, starting at 0. Row is less than main dot grid size. That is because our final is in the main method, so we have to reference that. And another for loop. And we're going to do the same thing for column plus plus. Okay, so what this is doing is saying start from 0, go through every row, start from 0, go through every column, scan every cell in this puzzle. So now we have 2 for loops. Now we're going to ask it a question. If Sudoku board, I'm looking at my notes here. I took notes because there's just a lot of explanation here. For row and column equals 0. This is an if. What's happening? Going through every cell. And if the cell is 0, that means it's essentially empty. We need to fill it with a 1 through 9. So this line of code is telling the computer to look for the empty ones so that we can fill it with numbers, which we're going to do with the next line. For, and this is a new variable that we're making, num to try. Number to try. It's a little, I gotta fit it, within here. So number to try equals 1. That's important because 0 represents spaces, but for the actual digits, we want 1 through 9. So we're going to start this one at 1, is less than or equal to grid size, right? Main.grid size. And that's going to be num to try plus plus. For the number that we're going to try, start at 1, go up when you find a 0, okay? So when it finds a 0, it's going to try a number from 1, and it's going to keep going up until in this next line, it reaches a valid 1. So we're going to call that. So we're going to call validator. What are we going to run through that? Let's go back and check. So we did Sudoku board, row, column, number. It's important that that order stays, okay? Because the method is expecting that exact order. So if you do it out of order, it's going to fuck everything up. So we got to go Sudoku board. Do I have to put int? Is that? We're just going to try without that. Sudoku board, comma, what was it? Row, comma, column, num to try. And num to try is effectively number. I don't know why they're not the exact same. I think it's because num to try is like a new, it's in this method, but it's the same number. Look at this. Look at this mountain of curly braces. We're going to have to deal with that. Once it sees if the number that it's going to try is valid, we need to place that number on the board. Okay, so we're going to go board. At the row and column, we're going to put num to try. Okay. If it's a number. Okay, cool. So, one more time. Go through every cell, find a 0, which means a space. In that 0, try a number, 1 through 9. See if it works, and if it is working, if valid placement says that works, place the number at that row and column, all right? Now we need some logic to backtrack. So if that doesn't work, like let's say it places a number, but then that number needs to be somewhere else, we need it to go backwards and try a different number. So that's what we're gonna do right now. Hold on. One thing real quick. So we have that checking if it's valid, if it's true, placing the number. So review the board. Okay, this next one is going to be another if statement. This if statement is actually going to see if the rest of the board can be completed. And this is the start of our loop. So if this is true, good job, it's complete. If it's not true, which is going to happen like a million times, we need it to go backtrack and start the recursion. The next thing we need to do is to begin the backtrack. So we're going to do, we need to reset that number that it tried back to 0. So we're going to go board, Sudoku board, row, column, equals 0. If it returns true, great. If it's not true, which is highly probable, it's going to have to go through a bunch of iterations of this. It's going to go down here, and it's going to reset that number right here, num to try, back to 0. If it's back to 0, we're going to go back up here with a return, 2 return statements. It's going to go back up here and do it all over again until it gets the right answer. Okay, so we need return statements to complete this out. What's wrong here? Hold on. Why does it want to? Okay. I don't know. Hopefully when we add these return statements, it's going to fix everything. Let's go return false. And then down here, return true. That cannot be right. So maybe this needs to be, hold on. Maybe this needs to be right here. This is so confusing. Let's run it. Let's see if it works. Okay, not that many errors. This is too many parentheses. Illegal start to type 18. Okay, so this is a problem. I know it's a curly brace that is causing it. So we got the class down. The class is right there, right? 4. Okay, so this one is maybe that's it. Dude, is that it? No, because now this one's open. Then that one's open. Dude, this is crazy. I hate this. All right, 21, it says we're missing a curly brace too. Let's try it again. All right, I guess it works now. Right down here. It's one of these two. Is the board complete? Is it not complete? If it's not complete, go back up here, find the next 0, and place a valid number. So now we need to execute it in our main method. If solver.solveBoard at the board is what we're passing through it. If it is true, we'll have it print this out. We'll say puzzle. Uh-oh. What the fuck? Okay. Puzzle solved. You did it. Winky face. Because you didn't actually do it. But you can tell people you did it. You just got to enter in all these numbers. All right. And then if it turns out, because some Sudoku sites will make unsolvable puzzles, which is like totally fucked up because you're just wasting everyone's time. We're going to do a print line that says unsolvable puzzle. It be like that sometimes. And we'll give it awkward face. Okay, let's run that. Please work. Please work. Unsolvable puzzle. It'd be like that sometimes. What? Interesting. If I know this one is solvable because I preemptively solved it when I was practicing this. Figured out the bug. Here's what was happening. So it says unable to solve the puzzle. I know this puzzle is solvable. What's happening is in the solver, the logic right here is bad. It is going through once, and if it doesn't work here, it's stopping at this first row. So it's not going through the whole board. So after the first row, or after the first column, you see this? It's like, yo, this is no good. We need it to go through the whole thing. And if it does go through the whole thing, I think it's going to give us the result that we want. So I'm going to move this to here. Then we'll go to main. See, puzzle solved. Just because we had this in the wrong curly brace. This sends it back to number to try. Try again. Originally when we had it down here, it was sending it back up to this, I think, and it was just like, all right, it's not working. We're going to print this out, but it's going to require another method, a print method. So we're going to go outside of this guy, and we're going to do public static void, and we need to void because we're just printing out a print line. It's not returning anything. If we didn't do void, if we did like string, it would have to demand a return statement, which what are we going to return, And we're going to pass through Sudoku board. So we're making a method, print board, we're going to run the board through it, and we're going to, basically we need to, and we've done this so many times, we need another 4 so that we can, iterate all the things we want to print. So we're going to go row, and we need one for the column, exact same. So we're going to do this, but we don't want the print line because it's going to print, it's going to print like all 80, what is this, 9 by 9, 81 numbers. We're going to print them all in a box. So to do that, we're going to go Sudoku board, and then right outside the for loop, as it keeps iterating through the rows and columns, we want to do this one. We want to leave in the print line, put nothing. We want a blank line so it just cuts it up. So it's not one long thing. It's like a stack. Let's see if it works. What happened here? Oh, we need another 4. Variable row might not have been initialized. All right. We're going to try out whatever IntelliJ wants us to fix. How do we fix that? Oh, okay. I see what went wrong. It's not working because we didn't establish these at 0. We got to call our print method. Print board, Sudoku board. And do we need to do the other part? I think, would this just work? Sweet. Okay. Finally. All right. We solved the puzzle, and now I'm just going to check a couple of these to see. Okay. That looks good. That looks good. Let's check one of the 4, 3, 2. That looks good. Let's check this box right here. It only has one of everything. Okay. The computer did it in like 2 seconds. Nice. All right. That took a lot of debugging, but that is a Sudoku solver. And if you wanted to do it yourself, you would just have to go through and change all these to the board that you've been presented with. That is my Java experience. I had a good time. Hope you guys had a good time. Catch you later. I'm gonna learn something else.